Hi learners, here we are going to discuss the very important topic called electrochemical series. See, first of all, you should understand what do you mean by electrochemical series. Here, the electrochemical series are nothing but elements arranged in the increasing order of standard reduction potential values. Those series is said to be electrochemical series or EMF series. I'm repeating again, when elements are arranged in the increasing order of standard reduction potential values, that particular series is called as EMF series or electrochemical series. Here, we are going to deal with the applications of EMF series or significance of electrochemical series. The first important one is how to determine the standard EMF. See, if you want to determine the standard EMF, there is a formula E naught cell is equal to E naught R minus E naught N. That means right side electrode minus left side electrode. That means cathode minus anode is said to be standard EMF of the cell. The second one is relative ease of oxidation or reduction. See, the metals which are at the top of the series are called as most reactive, and the metals actually which is the least, they are called as least reactive elements. That means the elements above hydrogen and the elements below hydrogen. The elements above hydrogen are called as most reactive, and the elements below hydrogen, they are said to be least reactive elements. So, if we talk about these, the elements which is on the top, okay, they undergo easily the oxidation. And the metals which is at the bottom of the EMF series, they undergo what? Reduction easily. So, let us take a very good example is fluorine and lithium. Fluorine is going to have positive electrode potential, which prefers reduction. And when you talk about this lithium, is actually is going to have less reduction potential, or otherwise I can say it is going to have higher oxidation potential, so it prefers oxidation. When you talk about the third one, anodic or cathodic reaction, the metals which is lying, okay, the sense like if we talk about the above, that is actually the metals which is lying above the series. Above means above hydrogen. They are highly more prone to corrosion because they are highly anodic in character. And the metals lying lower in the series, they are said to be noble metals, which will be what? Inert in character, which will not that much of reactive, least reactive elements they are, and they are less prone to corrosion. And then the fourth important one is the hydrogen displacement behavior. And I told you, the metals above hydrogen, they displace hydrogen readily and quickly because they are most reactive. And the elements below hydrogen, okay, they are the least reactive, couldn't able to replace the elements. Then here the fifth one is replacement tendency of one element by the other. When you talk about the metals which are above the hydrogen can displace the metals which is below. See, for example, zinc is above the hydrogen and copper is below hydrogen. Zinc can displace the copper and forms the product, or like it forms it undergoes the reaction. But when you go vice versa, that means copper plus zinc sulfate, the reaction will not take place because copper is least reactive, zinc is most reactive, will not displace. So from this, we can have an inference that the most reactive elements can displace the least reactive, but the least reactive will not displace the most reactive elements. The sixth one, predicting the spontaneity or feasibility of a redox reaction. And here we know E naught cell is positive. See, actually, we know a formula. E naught cell is equal to E naught R minus E naught L. Use the formula and you will be getting the value. If that value is positive value, then the reaction is feasible or spontaneous. And if that E naught cell value is negative, it is non-spontaneous or not feasible reaction. So if it is like feasible, delta G naught is negative. Non-feasible means delta G naught is positive. And then the last one here, determination of standard free energy, that is delta G naught and equilibrium constant. Here comes the formula, log K is equal to minus delta G naught by 2.303 RT, which is equal to NF E naught by 2.303 RT. By using this formula, you can able to calculate delta G naught by holding equilibrium constant. So this statement, this formula is giving a relationship between standard free energy delta G naught and equilibrium constant Kc.